In this lesson, we're going to talk about how to solve rational exponent equations. If you remember back to some of our previous lessons, we dealt with simpler rational exponents, things like 9 to the 1/2. And in a case like this, we talked about that the denominator number told us what type of root we were to take, and the top number was the exponent that we would apply to that answer. So in this case, we would take the square root of 9 and then raise it to the first power. In these problems that we have today, we've got a variable raised to this rational exponent. So we're not going to solve it quite the same way, but it is a good thing to remember that the denominator represents a root and the top number represents an exponent. So the first rule that you want to follow is if you want to solve for x and you're wanting to get rid of all the things around the x, this particular x is actually underneath a radical. When you locate the rational exponent and you ask yourself, what is this exponent touching? It's touching the parentheses, which means all of these numbers that are in the parentheses are actually underneath this radical. So typically we would isolate the radical, which in this case, this radical is already isolated. There's nothing multiplied, divided, added, or subtracted to this radical. And then we are going to use the reciprocal exponent to get rid of this exponent, to get rid of this radical. But whatever we do to one side of the problem, we have to do exactly the same thing to the other side. Now, there's one more rule. Also, if you think back to previous lessons, we talked about that if you ever put an even root into the problem, then you also have to put a plus or minus sign into the problem. So when you flip and you use the reciprocal, you need to double check the denominator. This particular root is even, and because it's even, I need to make sure that I have a plus or minus sign on the answer side of my problem. So on this side, when I raise a power to a power, I'm going to multiply these two powers together, and that just becomes a power of 1, which means I do not have to write that any longer. And so the right-hand side of this problem will just be 7x minus 8. On the left-hand side, if I take the square root of 25, I get 5. And then when I raise that to the third power, I get 125. Now, because I have a plus or minus sign, I am going to have to break this into two separate equations. I will have 125 equal to 7x minus 8, and I will have negative 125 equal to 7x minus 8. In this first equation, I will add 8 to both sides, and that gives me 133 equal to 7x, and then I'll divide by 7, so x is equal to 19. That's my first answer. On the second side, I'm going to add 8 to both sides, which gives me negative 117 equal to 7x. And then I'll divide by 7. And since this does not divide evenly and it is reduced as much as it can be, I'm just going to leave it like it is, negative 117 over 7. And so I've got these two answers. All right, in this second example, I'm wanting to solve for b, and I do notice that I have this rational exponent again. So I'm going to ask myself, what is the exponent touching? It's actually touching a parentheses again, which means all of this is part of a radical. And I don't have anything that I need to move away from this radical. So I can go ahead and use the reciprocal, which is negative 5/7 on both sides of my equation. Now, since a lot of us don't know our seventh roots, You may want to pull out a calculator for this, and so I'm going to use this as an opportunity to show you how to enter this in a calculator. Remember, if you want to put a fraction into your calculator, depending on what type of calculator you have, you can use alpha y equals enter. It'll give you that fraction bar. And I'll go ahead and put 1 over 128. And if I want to raise it to a power, I use this button right here, the upward arrow, and I'm going to put negative. Then again, I've got alpha y equals enter, 5 over 7. And that gives me an answer of 32. Now this time, since the denominator of my reciprocal is an odd root, I do not need a plus or minus sign, and I can go ahead and just solve. I'm going to divide both sides by 8, so b is equal to 4. All right, number 3 gives us an example of a problem that doesn't have any parentheses. Our two previous problems both had parentheses in them. This time, again, I'm identifying where the radical is, this 1/2. What is it actually touching? It's only touching the a. So this is my radical. And if I want to isolate that radical, get it all by itself, then I'm going to start by adding 1 to both sides. So I've got a to the 1/2 equal to 9. And then now I'm going to use the reciprocal exponent on both sides. So I get a equal to, and this is just 9 squared, which is 81. And once again, when I did that reciprocal, I did double check the denominator. It was an odd denominator, so I did not need a plus or minus sign, and this will be my final answer. In this last example, I'm going to first identify where my radical is. The 6/5 is touching this parentheses, so all of this is part of my radical. The radical is already isolated, so I can go ahead and use the reciprocal exponent on both sides. I'm going to double check the denominator of that reciprocal exponent. It is an even root, and because it's an even root, I'm going to make sure that I put a plus or minus sign on the answer side of my problem. On this left-hand side, I get just what was inside the radical, x plus 9. And on this right-hand side, if you need to use your calculator, remember, you're going to do 64, use the upward arrow button. And if you don't want to use the alpha y equals enter, you can enter that as 5 divided by 6. It'll work that way also. So the answer to this one is 32. And because it has a plus or minus sign on it, again, we need to break it into two separate problems. X plus 9 equals positive 32. X plus 9 equals negative 32. If I subtract 9 on this left equation, I get x equal to 23. And when I subtract 9 in this right equation, I get x equals negative 41.